For our next example, we're going to examine g of x equals the square root of x. Now its domain is x greater than or equal to 0. Remember, be careful about the inclusion versus exclusion of your endpoints. 0 is in the domain of the square root of x. All right, so our graph looks like this. We have a point here, and it looks like so. All right, so if we were to be asked to examine the end behavior, so the limit as x goes to infinity of the square root of x, that limit's equal to infinity. And again, that comes along with basic knowledge of the behaviors of the graph of the square root of x. Okay, this graph is going to infinity. It's strictly increasing, but it's increasing at a decreasing rate. It's concave down, and that's something that we'll explore in much greater detail in calculus next year. Now, if someone was to ask you about left-end behavior, we couldn't really answer this question. The reason being is that this graph, we can't follow the x-axis to negative infinity due to the domain restriction. So this isn't a question that's going to come up or should come up. Right, if somebody were to ask you this, limit as x approaches 0, the square root of x, we can't look at that question either because there's no way for the two-sided limit to exist at x equals 0. Again, because of that domain restriction, the endpoint discontinuity, we call it. So the farthest left we can go along the x-axis is approaching 0 from the right. All right, so if someone was to ask you the limit as x approaches 0 from the right of the square root of x, this is something that we can evaluate through direct substitution. It is the square root of 0, which is 0. All right, this graph has no horizontally asymptotic behavior because we don't have an end behavior limit that bears that out. All right, we would need the limit as x goes to infinity or the limit as x goes to negative infinity to be equal to a real number, and that is not the case here.